Hey everyone! In this lesson we're going to talk about some of the different characteristics of the Earth's surface. So what I was hoping to do in this lesson is just give you a bit of an overview about some of the big features that we see on the planet's surface and just talk a little bit about some of the processes that are associated with each of those things. So for example, things like um, erosion and maybe the way energy moves around the planet and things like that. So um, in this lesson, we're just going to talk about a bunch of different features of the planet. There's not going to be too much detail about any one of them in particular. We'll just spend a couple of minutes talking about each of them. So when you look at Earth from space, um, it's fairly clear that there are only two significant features, and honestly, maybe just one significant feature of the planet when you're looking at it from so far away, which would be the ocean, um, or the collective oceans of the world that cover about three-quarters, a little bit shy of three-quarters of the planet's surface. Um, they take up a lot of space on the surface of the planet. There are if you look at Earth from a certain angle, um, like if you look at a picture of Earth from a certain angle, you can actually find a picture that's got like a little bit of Russia and maybe a little bit of Japan out here in one part, maybe a little bit of Australia down here, maybe a little bit of South America over here, and maybe a little bit of North America over here. And that's pretty much it. The rest of that ocean is basically empty. There's a few islands over in this space here, and there's Hawaii and stuff somewhere over here, or maybe a little bit more this way, um, somewhere over here. But like for the most part, there's one half of the planet where if you look at it, it's basically devoid of any land. So um, the most prominent feature of the planet is really just a giant ocean. It's just the most of the surface is covered in water. But the second prominent feature, if you get in close enough to be able to tell apart more than just the blue of the ocean, is the continents. The different continents of the planet are certainly a prominent feature, but there are plenty of differences between different parts of the different land masses. So, some places will have deserts, some places will have mountains, and we're going to talk about features like that and why they're important or why they exist. One final point about just the features of the Earth's surface and why I want to talk about it in this lesson is that it's important to think about. I'm not going to spend too much time emphasizing it in this lesson, but it's important to think about how the different components of the planet's system, this Earth system that we're a part of, affect each other and affect the Earth itself um, in different ways. And the key thing about the surface of Earth is that it's affected by all four components of the Earth system. So if you look deep inside the Earth, you won't really find living things. You won't find water, like really deep. If you're down in the mantle or something, you're not really going to find water. There's no atmosphere. There's no biosphere. That's actually under the lithosphere. It's not really affected by any of them except maybe a bit of the lithosphere and possibly parts of the biosphere and stuff. Like there are going to be contributions from the atmosphere and the hydrosphere when you're talking about things deep inside the planet, but those contributions become really, really apparent when you're looking at the surface because the atmosphere is responsible for things like erosion and wind patterns and weather systems. The hydrosphere also drives some of that with the weather systems and stuff. The hydrosphere is responsible for ocean currents and the way rivers move and why lakes are where they are and the ocean water temperatures and how energy can move from the tropical waters near the equator out towards the polar regions via the ocean currents and things like that. The lithosphere, the land itself, and how it interacts with other pieces of the Earth's crust, how the different features that we see in the landscape, like mountain ranges and oceanic trenches and things like that, how those things form, that's all related to the lithosphere. And then the biosphere is everything that's living in that space, on the surface of Earth, just under or just above the surface of Earth. That's all part of the biosphere as well, everything that's living there or has lived there. So um, talking about the surface is the easiest way to see the different effects of all four of these different spheres, all four of these different components. And that's why I think it's important just to take a few minutes to look at an overview of some of the different features. There are plenty of features that we're not going to talk about today, and there's way more detail that you could go into for the ones that we are about to talk about. When it comes to things for assignments and tests and stuff, um, I will focus on testing you on the things that I've asked you in these lessons. And when it comes to actually studying for a test, it will be everything that's from these lessons or from assignment solutions and stuff that I post for you guys. But for assignments, to encourage you guys to read a little bit more, I'm thinking of adding in some components to the assignments where you have to do a little bit of reading on your own online, so that the answer is not just presented to you in the lesson. We're flamingos now. This is a step up from the way my science classes would run with the parrots, in that the answers, because we're using the internet and stuff, the answers could be something that I could ask you to go and find somewhere online. But I'll be more clear about that when it comes to assignments. But the main idea I want to sort of drive home here is that the different components of the Earth system can affect each other and can affect the different things that we're about to talk about in so many ways. And I really, really, really want to encourage you guys to just do a little bit of exploring. Pick one of the things that we talk about that interests you, or maybe you were hoping for me to talk about one specific thing and I don't talk about it. Let me know. We can talk about that kind of thing in our Friday meetings and things like that. So let's get into it now. So we'll begin by talking about some of the prominent features that we find on the continents. Now, obviously, you could argue that if you're looking at Earth from a distance, the continents themselves are the prominent features among a world that's just ocean. But suppose we zoom in close enough that we can see different aspects of the continents. So we can see different parts of them and how this part of the continent doesn't look like that part, and this one has mountains and that one doesn't. What's going on? So there are a whole bunch of prominent features that we can look at when we're talking about continents, and I've listed 6 of them here that we're going to discuss just briefly today. If there are more that I haven't talked about, let me know. Leave a comment, write it down somewhere, and we can talk about it in our Friday meetings. And if you have any questions, of course, then let me know and I'll answer those for you. So the first one that I want to discuss is volcanoes. And the reason I want to talk about this is that volcanoes are obviously pretty cool to look at. Um, you know, talking about eruptions and stuff is exciting and maybe a little scary. If you're thinking about things like how did the dinosaurs die, then volcanoes can come up as a potential cause for that. If you've ever read up about the supervolcano in the US, in Yellowstone National Park, you'll find that it's kind of sort of supposed to erupt sometime soon, and if it does, that could have severe impacts on the whole planet, or at least the northern hemisphere. So volcanoes are important. I think they don't really get the sort of the attention that they deserve aside from the pretty pictures, because there is more to them than just being dangerous or tools of destruction and stuff. They are actually really good for the area right around them when they're not spewing lava everywhere, because if you explore regions right around a volcano, you'll actually find that the soil around volcanoes often tends to be really good for growing plants. And that's because a lot of the nutrients and a lot of the minerals and things that you would want to find there come from the stuff that comes out of the Earth's mantle when a volcano erupts. So basically what you have is you've got your planet's crust, and then up here you've got this volcanic cone, and then there's a cavity, a hole that goes down into the mantle of the planet, and hot magma that's got all of these different things that we need up on the surface, all these different nutrients and stuff. They all come up through the magma and then spew out in this during a volcanic eruption. So that's my intro drawing of an eruption there. So this is just one component of what I've written here. This is part of a large-scale system that cycles material through the different layers of the planet. So it's important to note that the material that we see on the surface today might have been stuff that was molten in the mantle millions of years ago, or might be molten in the mantle millions of years from now. So a lot of the same materials that are on the surface today are things that have been cycled up from the mantle, or things that will eventually cycle back down to the mantle, probably both. And it's important to recognize that volcanoes are just one component that contributes to this cycling and recycling of material through the different parts of the planet. It allows us to uh, gain new minerals and nutrients and materials, and it helps to build new crust. We'll talk about that a little bit more, but it is responsible for creating new crust, because as this magma cools, when it lands on the surface and it cools, it hardens and forms igneous rock. We'll talk about igneous rocks more later on in the year, and then eventually, the volcano gets bigger, or the area around it gets covered in this new layer of crust that's formed from the magma that lands and then cools to form this rock. Lastly, volcanoes form near plate boundaries, which we'll talk about. I believe I have a picture on the next slide. I'll double check. If it's not there, I'll draw you a quick one. Yeah, so plate boundaries, basically the planet's crust is fractured, is broken into a bunch of different, pretty big pieces for the most part. But on the edges of those pieces, where one piece meets another, we tend to find a lot of volcanoes, and a lot of earthquakes and stuff happen in pretty similar areas. So those two can be linked together. Yeah, okay, so here's just for one, as everyone would like to see probably, here's just a pretty picture of a volcanic eruption. They're always pretty cool to look at. But if you look at this diagram up here, that's what I want to draw your attention to, because all the red that you see in this diagram is where volcanoes are found. And it's interesting because if you ever look at a map of the plates, the big continental pieces that make up the crust of the planet, the edges of those plates follow really closely with these volcanic chains. So there's a Pacific plate that's basically the size of the Pacific Ocean, um, and follows these sort of lighter blue areas down here. Those are all, now I'm just approximating now that it's something like this, but you'll have a plate that you can basically tell where it stops based on where the volcanoes are found. And actually the lighter blue bits in the ocean, like this one here, um, are basically underwater um, mountain ranges, which we're going to talk about next. But um, and those are also responsible for creating new crust in much the same way that volcanoes are. So we can use volcanism and the locations of earthquakes and stuff to figure out where these different parts of the Earth's crust actually, where the different pieces end and where a new one begins. So now we'll go on to talking about mountain ranges. So these basically form as the result of tectonic activity. So by tectonic activity, I mean that those plates that we were just discussing, those fragments of the Earth's crust, they crash into one another. And so when you have one plate that's not the best color. Hang on, let me do this in black so that you can see it clearly. So suppose you've got one plate floating on the mantle, so the mantle is like down below, and then you've got another plate next to it, and suppose that they're moving towards each other. So we've got this plate moving that way and this plate moving that way. Then when they collide, you might get something like, so you've got the mantle underneath, but then the two plates have collided with one another and they've lifted each other up. They sort of crumpled and pushed each other upwards, and then that could form a mountain or a mountain range. So obviously I've got this big gap in the middle here, which you wouldn't find, but basically what happens is your crust goes from being flat like this, and then the plates collide, and then all of a sudden you've got a mountain in the middle. And if this happens over the scale of many, like if this plate is crashing into the other one, chances are it's crashing into the other one across a stretch of a few hundred or a few thousand kilometers. So it forms mountains all the way along that chain. And that's the kind of thing that we see in places like the Andes, where the Pacific plate, so I can't go back a slide on this, unfortunately, but basically we've got South America, which looks something like this. That's a really simplistic drawing of South America, but we've got South America there, and we've got the Andes kind of going down like this. And the Pacific plate, which is that giant oceanic plate over here, is basically moving this way and crashing into South America. Now it's a slightly different setup than what I've drawn in here. What's happening there is that the oceanic plate, so the Pacific plate, is dipping downwards when it crashes into South America, but then the South American plate gets pushed upwards. And so what we get is that if the South American plate is being pushed upwards over here, and over here, and over here, and over here, and over here, we're going to get mountains all along that chain. And so that's where we get the Andes, is basically because this Pacific plate is colliding with the South American plate that's over here. Now, because of this collision and the fact that the plates moving together causes the mountains to form, we also get that some mountains are still growing because of this. If the plates are still colliding, the mountains are going to get taller and taller. And this is what we see with things like Mount Everest is still getting taller because the Indian plate is still colliding into the Eurasian plate and is forming these huge mountains as a result. Now, one thing I haven't really talked about here yet is the rain shadow effect, but I'm going to discuss that on the next slide. So the rain shadow effect, here's a pretty picture of a mountain or a mountain range, and then up here we've got the rain shadow effect. So basically the way this works is pretty simply, you've got wind that's holding some moisture. Let's say it's wind that's coming over the ocean, because we've got a little body of water right there. So we've got wind that's coming from over the ocean, so it's containing a lot of moisture, and then it runs into a mountain, so it gets pushed upwards, up the mountain slope. Now when it gets up near the top of the slope, all of that moisture starts to condense and falls as precipitation. So we get rain or maybe snow if it's really cold, and all of that precipitation falls on the mountain because it's sort of, the mountain is pushing the cloud upwards, and that accelerates this process of condensation and precipitation. So the fact that the cloud is moving upwards because of the mountain causes it to precipitate basically right on top of the mountain. The problem is that once all of that precipitation is gone, there might still be a little bit of precipitation that makes it to the other side, but you might just get dry air that goes to the other side, and it has nothing left to give in terms of rain or snow. There is no precipitation. And so what we get on the other side over here, like on the right side of the mountain in this picture, would be a desert, because a desert is just an area that doesn't receive very much precipitation. And if you've got the mountain hogging all of that precipitation because it's pushing the clouds up, then there's no moisture left in the air that makes it over the mountain and then rains on the other side. So mountain ranges, sure, they look great and stuff, but they can also have some far-reaching consequences because they can be responsible for the formation of deserts. Moving on to deserts. Deserts can form for a few different reasons, but the two main ones are that they form as a result of some really complicated patterns of the movement of air in the atmosphere, which is sort of linked to that idea of dry air being found in certain regions. So you'll find that there are these regions around the Earth. So hang on, let me draw in a little Earth somewhere. If I draw in an Earth down here. So we got Earth here, and let's say we got the equator about here, something like that. Now I'm going to draw in Africa. It's not going to be perfect, and the location relative to the equator might also not be perfect, but something like this. Here's Africa. That's not perfect, but whatever. So here's Africa, the Middle East towards Asia is over there, Europe is going to be up there. And what we get is we have a desert in this area here. We've got the Sahara Desert here, and we've got a desert in Namibia, the Namib Desert down here. And so basically what we find in these areas as well as others is that there are just these regions of the planet that are sort of in sort of around this range up here and this range down here where we find deserts. It's sort of the same distance away from the equator. So I'm saying like this distance here is similar to this distance here. And that's because of the result of some complicated atmospheric patterns, which we're not going to talk about now, but we might come back to a little bit later when we're discussing the atmosphere in more detail. And the other way that deserts form, the other main way, is through that rain-shadow effect that we just talked about with mountains. Now, one final point to note about deserts and why I think they're so interesting is that because of the harsh climate and lack of precipitation, lack of water, we find some really, really hot deserts and some really, really cold ones. And either way, it seems like such areas would be inhospitable. It would be difficult for life to take hold there or to stay alive in places like that. But they really are capable of hosting a really diverse ecosystem. And so this gives us an idea that that life, once it really took hold on the planet, it's really, really hard to get rid of it, because you'll find life in every corner of the planet, including the middle of a really, really hot or really, really cold, dry desert. And here, just for fun, here's a little picture of a desert. I've included one that has a picture of some plants and stuff there, just so you can see that there is a little bit of life that's been able to take hold and somehow stay alive, even though the desert is so difficult to live in. So moving on, we now look at rivers. Now, rivers are important because if you look through history, they've been really, really important for people. They bring in a lot of nutrients for plants, so they're great for crops and agriculture. They offer a great transportation system for people, so if you needed to get from one place to another, especially in like ancient times, this would be your best bet for going somewhere that wasn't by foot across a desert or something. So for example, if you look at ancient Egyptians, they all just congregated right around the Nile because everywhere around that was desert, but the Nile offered them a reliable water source. It flooded at times that they could predict using the stars and stuff. They'd be able to predict when it would flood, and they could make use of that extra flood water. It was great for crops. It was great for transportation. And if you look at maps of an ancient civilization, like of where ancient civilizations were in the world, I think I have one on the next slide or two. You can see the dependence that people had on rivers then, and we can still see the dependence that people have on rivers and just on water in general today. When you look at where cities are and how so many cities are near a coast or near a river or near a lake or something like that, so we can gain an understanding of how important rivers are just by looking at where people are found. Now, it's also important to note that rivers can shape the land through erosion. So basically, if the river erodes away the rock, then you can form big holes or trenches in the ground, which is basically what we get when we're looking at canyons. And so that we're going to talk about that in a second as well. So first, here's just a picture of the Nile in Egypt, and this is somewhere around Cairo, and you can see like it's not a small river by any means, but everything around the river, you can't really see it in this picture, but everything away from this river is basically a desert. So if you can settle down and live right around this river, it kind of solves a lot of your problems for you. So it was really important to the ancient Egyptians, and it's still important to Egypt today. Now here's a map of ancient civilizations from thousands of years ago, and you can see that I think black should be good. So yeah, you can see here. So okay, over here we've got ancient China. They are dependent on a river there. We've got dependence on a body of water, possibly a river, possibly just the sea. Down here, the Indus River Valley has also got an ancient civilization there. We had Mesopotamia over here. We had Egypt over here. We had Ghana and Mali over here. There's lots and lots of different civilizations that we saw take hold in areas that had a river or at least some sort of water source. But you can see in most of these cases, it is a river that they seem to congregate right around, and that's no coincidence. Rivers were very important to humans back then, and they have lots of benefits for the land around them. As we can see, if you've ever looked at a picture, I don't have one in this slideshow, but if you've ever looked at a picture of Egypt, that's like a satellite image. You basically get that the whole country is. Hang on, let me see if I can draw this. So we've got Egypt that looks like. Egypt looks something like this, and the whole country is a desert, except for right around the Nile. And there's this big green space that just follows the Nile down through the northeast corner of Africa, and then we've got the actual Nile in there somewhere. But yeah, everything else, the entire rest of the country basically is just a huge desert, and then there's just this one long, thin oasis of greenery and water, and that's where you find most of the people. And it's quite remarkable to see that that kind of effect can be had by a river, even in such a big desert and such a hot part of the world. So now we move on to talking about glaciers. These can be important because they are huge reservoirs of ice, and in particular, they're huge reservoirs of water, and especially fresh water. So the important thing there is that we, as a civilization, obviously, and as a species on this planet, we need water to survive, but in particular, we need fresh water to survive. So yes, the planet is covered mostly in water. The oceans are humongous and contain lots and lots and lots of water, but it's salt water, and we can't use that for the things that we need it for. So we need fresh water, and we're actually in a point in time now where fresh water is becoming a bit of a scarce resource. We've got some places around the world that are already that already were struggling to get enough water, but there are now places that had water that are now running out of water, and they've been basically forced to shut off the taps because they don't have enough water to go around. Um, and the reason that that's important is that a lot of the fresh water on the planet is locked up in these glaciers. And it's not easy to just go and, get the fresh water from there. There are these huge, huge chunks of ice way up in the polar regions or in mountainous regions. Um, and one of the issues is that as the glaciers melt, for one, they stop reflecting sunlight back into space uh, as they melt, which creates a whole bunch of problems for us down here because the planet absorbs more heat. You can see that down in this last point here that while they exist, they reflect sunlight back into space, so that helps to keep the temperature of the planet at a controllable level. Um, but also, as they melt, that fresh water is being lost to us because it just gets mixed in with the ocean when it flows there. Um, a little bit more about glaciers. They had a huge, huge impact on shaping the landscape in North America and in Europe during the last ice age. Um, and they leave a lot of debris when they retreat. So they would come down from the polar regions and they would cover all of Canada and Scandinavia and parts of the United States and stuff like that. And then when they went back up towards the polar regions, they left behind a lot of stuff, a lot of debris, a lot of material that we can see today as evidence of glaciers passing through this region 10,000 years ago. Um, and the sheer weight of the glacier also causes the land beneath them to get compressed and pushed down. So actually in my town, there's a part of the town that's just on a different level compared to the rest. Like it's just up on a hill. Like the town is like, there's some up here and then there's a lower part down here. And the idea is basically that there was a big glacier that went through this part of the town, but not that part of the town. And so the land got pressed down by it and is still ever so slowly pushing its way back up to where it used to be. And here, just for fun, is a picture of a glacier, which you can look up more if you wish. There are also some pretty cool YouTube videos if you want to look at videos of glaciers up close or glaciers fragmenting and falling apart. Lots of cool stuff out there. And lastly, for the continental features, we're going to talk about canyons. Now, these are features that come as a result of erosion. So we can see that it's basically evidence that there used to be water passing through this area. So you could have a river that erodes down the rock to such an extreme point that basically you're left with a canyon, even if the river eventually dries up. And you can get the same thing with lakes and seas, especially if they're connected to rivers and stuff. You get these long, long, huge trenches where the water used to pass through and erode away huge, huge amounts of the rock. And actually, um, this idea that canyons exist because there used to be water passing through here is actually a sign that we look for when we're looking at planets out in the solar system, when we're looking for evidence of water there. If we see canyons like this and these big trenches and stuff, there's a pretty good indicator that there used to be water there. So here's just a picture of a canyon. You can see that there is still like a stream or a river that's passing through down at the bottom there, down here. But all of this stuff gets eroded down by the water and leaves these huge, huge valleys and huge canyons. So now we're going to spend just a few minutes. I know it's already been 35 minutes of this lesson, so we're going to try and wrap this up in the next 10 minutes or so. We're just going to take a few minutes to look at some of the prominent features that we also find in the oceans. Now, of course, there are probably plenty that I haven't listed here. I'm just going to talk about a few of them, just to give you something to think about when you're thinking about the different parts of the Earth's surface and how they're all connected to one another. So let's begin. So if we begin with mid-ocean ridges, these are basically mountain chains, like what we saw earlier with mountain ranges, except these ones are on the ocean floor. So that was basically what you could see when you had, like when you got South America on this side. South America looks something like that. And then you've got Africa on the other side. Something like this. And then there was just this line, this lighter blue line in between the two that sort of passed right here. That is a mid-ocean ridge. And so that's one of these underwater mountain chains. They are similar to volcanoes in that the magma rises up from the mantle and it lifts up part of the ocean floor, which is what creates this ridge. So when you look at the ocean floor, it's flat, and then at this ridge, it's uplifted a little bit, and then the magma comes from that gap, and so the magma comes up from right here, and it lifts up part of the ocean floor and deposits new material right around where it came out from. So this part of the ocean floor just gets thicker, and so we get these underwater mountain ranges basically because of it. Now the difference here is that before, when we were talking about mountain ranges, we were talking about two continental plates that are colliding. So we talked about a plate here and a plate here that crash into each other and then form a mountain, so form something like that, because they crashed into each other. What we have with the mid-ocean ridges is actually that as the mantle comes up from here, it pushes the crust away. It pushes the crust that way and pushes the crust that way, and this is what we call sea floor spreading. So basically, the ocean is getting bigger because this new crust is forming and is pushing the oceanic crust away on both sides. So what we get at this, like in this ridge down here, is we get that the crust will be pushing away in this direction, and it'll also be pushing away in that direction at these ridges, provided that that part of the ocean is in fact growing. So here you can see pretty much exactly what I was just trying to draw out for you. If you take a look at these, at the white areas here, don't worry about all the lines themselves, but if you look at those arrows, you can see right in here, we've got that the arrows are pointing in opposite directions, which is basically telling us that South America is moving this way and Africa is moving that way. So the Atlantic Ocean in the middle must be getting bigger, and that's because of this mid-ocean ridge that's going all the way down the entire Atlantic. And then over here, if you remember from what I was talking about before with the volcanoes, here are the sort of the edges of parts of the Pacific plate, and it goes all the way around here and down the coast of the Americas, and we see volcanoes all along this part here, and over here we see mountain ranges, we see volcanoes, and it's because of all of these plate movements. So we can see that these things are all super connected. The volcanoes, the mid-ocean ridges, the mountain ranges, the plate tectonics, they're all connected in this way. So next thing I want to look at, this is something that I was talking about a little while before when we had the ocean plate moving beneath the continental plate, and this results in the formation of a trench, of an oceanic trench. And basically what this does is it helps to recycle material down into the mantle. So we get that we've got our crust that basically gets dipped down into the mantles, and we've got another piece that might get pushed up like this when they crash into one another. So this piece is moving that way, and this piece is moving that way, and then this piece dips down into the mantle, and this part right here at the front end of that, it's dipped down into the really, really hot mantle. So it just melts. And then that material gets recycled through the mantle, maybe somewhere else. There's a volcano or a mid-ocean ridge or something, and that material, it melts here, it gets recycled, it moves through the mantle, it stays there for like 1,000 years or tens of thousands of years, and then it comes back up through a volcano or a mid-ocean ridge or something somewhere. So we get that material gets recycled. And once again, this gives us that picture that the whole planet is ever so slowly recycling itself. It's creating new material from its mantle, and then it's discarding the old material. It's recycling the old material from its crust by dipping it back down into the mantle where it melts. So here's just a couple of pictures. This one here is a picture of the thing that I've drawn out a couple of times now. So we've got the continental plate, or sorry, we've got the oceanic plate dipping down below the continental plate. This one over here would be the continental plate. And the oceanic one is heavier, so it gets pushed downward into the asthenosphere, which is one of the layers of the mantle, and then sort of the front end of this chunk, they haven't really drawn it in, would melt, and then that material would get recycled elsewhere in the mantle. This thing over here is just an image of, it's like a satellite image sort of type thing, more like a simulated image showing like an elevation map of Challenger Deep, which is the deepest part of the deepest trench in the ocean. So you can sort of see that if you're looking at this from like a bird's eye kind of view, you can tell that the darker colors means it's getting deeper and deeper. So you can see that there are these variations in how deep the ocean is up until you get to here. And this whole thing is a really, really deep trench, and it forms from a process that's basically like what we see over here. So now we'll talk about ocean currents. There's just two more points, so hang tight, and then we're done for today. So with ocean currents, basically they're responsible for circulating nutrients and material and energy through the water, through oceans. And so basically these currents cycle heat energy to different parts of the planet. And I'm going to show you in the next slide a map that shows you how warm waters are carried from the tropical regions up towards the polar regions, and they warm up the areas that are around there. One important point is that oceanic currents are in danger of changing or disappearing in unpredictable ways because of climate change. There's just a whole mess of stuff that's contributing to it, and it could disrupt this natural flow of the currents, which could cause serious, serious problems to lots of people. So here's a map of ocean currents around the world. One of the most significant ones is over here on the left, this thing here, which is the Gulf Stream. So basically we've got warm ocean waters here in the red that come up from the Atlantic and from the Gulf of Mexico, and they move up this way towards northern Europe, and then the warmer waters there that have just come from the tropics, they create a more moderate kind of climate for Scandinavia and for the UK and places like that, and then that water sinks and cools and comes back down. Now, if this Gulf Stream were to shut off, then this warm water that's moving towards Europe wouldn't be going there anymore, and so the waters around there would get much colder. The UK and Scandinavia and other parts of Northern Europe would get much colder as a result, and that could be a problem for a lot of people that aren't equipped to deal with that, because normally we don't see, the UK is about on par with like mid to northern Canada for latitude, but the climate doesn't really seem to match, and the folks in Britain aren't prepared to deal with a northern Canadian climate because they've got the Gulf Stream helping them out. If the Gulf Stream were to shut off, then the entirety of the UK would be as cold as mid to northern Canada, and that would understandably be a problem for everybody that's living there. And lastly, we'll just talk about geothermal vents. So these are basically, they're basically vents at the bottom of the ocean. There are these areas from which hot gases and material and nutrients and all of that stuff that we could want are spewed forth from deep within the earth, and these come out through the ocean floor. So they're really deep down there at the bottom of the ocean, and they're spewing out new material, they're spewing out heat, nutrients, minerals, whatever we want, and they, as a result, because of the heat and the nutrients and stuff, they're really good for the organisms that are living near the bottom of the ocean. And some of those organisms have basically developed their own form of photosynthesis, but instead of photosynthesis, because there's no sunlight, it's chemosynthesis. Basically, they make their own food using the stuff that comes out of these geothermal vents. And here are just a couple of pictures of the geothermal vents. I don't know for sure if the image on the right is one that's been altered to show different like chemicals or anything with the colors, but if those colors are actually the way it looks or similar to the way it looks, then chances are the variety of colors is indicative of lots and lots of different life forms that live right around there, because this is a great source of nutrients for them. But yeah, this is basically what geothermal vents look like. All right, so that's about it for this lesson. I know it's been quite long. It's almost 50 minutes now. So if there was anything that you were hoping that I was going to cover that I missed, let me know so we can discuss it someday. Otherwise, just think about some of the things that we've discussed here. Try and see if you can piece together how the different components of the Earth system interact with each other in a bunch of these different ways. Things like the canyons are made out of rock and therefore are probably connected to the tectonic cycle with the recycling of material for the crust in some maybe difficult to see kind of way, but they're also connected to rivers, which are part of the hydrosphere and the water cycle. Erosion from the atmosphere, all of those things are combined together to form some of the features that we see in the landscape. So just think about those kinds of things. If you have a favorite feature, let me know, and we can talk about it in one of our classes. But otherwise, I will see you all in the next video. Have a good one.